Spatial invasion. Am I gonna have to implement the invasion algorithm or the invasion defense algorithm? In assembly, of course. Let's find out. The cargo hull has become infested with space rats. Looks like we're gonna have to defend. We have hooked your machine up to our advanced robot. Oh. To our advanced robot, and we want you to program it to shoot the space rats with lasers. Wow. Can you imagine? Be aware that the laser can only shoot when there are no longer laser beams already in flight. Oh goodness, this sounds like an incredibly difficult problem, actually. Check robot page for instruction on how to program him. There is a link to that page in the program editor as well. Robot page, the robot. I remember unlocking the robot at some point. Wow. The screen shows the robot and his surroundings. The robot lies one tile ahead. I don't see. Okay, this. Oh, the robot sees one tile ahead. The name and ID are shown up here. Looking at. Okay, seeing 40 crate. Whoa, this sounds like an actual programming challenge, which you would work on using an actual programming language, though it's still not entirely clear to me how I'm supposed to kill rats. So what exactly I need to do? Have robot controls, turn left, move forward, turn right. Enjoy the moment. I guess do nothing. Nope. Use action, enter, shoot laser, tab. Oh, use arrow keys to play around. What? Oh, I'm using, I think, right, I'm just trying to use arrows because... Are they gonna kill me? So this is actually Space Invaders, is all this is. Okay, shoot laser. Do they seriously expect me to win a game of Space Invaders? Using assembly programmed robot. This is a difficult task. Okay, let's try to move. So turn left, let's say. I cannot wait. No, it says use arrow keys. Oh, I died. Space rats got too close. Our decoration only, the hearts. Decoration only. Okay, so we can only turn and move forward. We cannot move back or anything like that, but I can move. Right, and I can kinda cheese them like so. But it doesn't actually help. Yeah, I'm dead. Okay, what's up with this? I can move the box. Let's enjoy the moment. I cannot enjoy the moment. On keyboard. Okay. The laser passes through one of them. But what do I see? Ah, seeing 0, nothing. Seeing 33 space rat. Kill. Kill. Nothing. Well then chill. Okay, well, there might be an easy way to do this. By just shooting when I see a space rat. Yeah, so I can do, you know what I can do? Okay, how do I restart? Reset. Use action, enter. I don't know what use action means. But Just kill me already. I cannot. Okay. So here's my first thought. Oops. So just get out, right? Go to the edge, for example, or I don't even need to go to the edge, I think. And then just stand, because they will go down. Actually, no, they go down every time they go left and right. So, so my first thought was, so let me just try to demonstrate it. So, if I'm just standing here, right, I'm basically safe to keep shooting my laser, and they cannot kill me. Well, now they can, but originally they couldn't. Right, I can just... Huh. Okay. This is a really annoying control scheme, actually. I'm trying to come up with something simple. Something incredibly simple that I would be able to easily program in assembly. So, like, stand over here and just shoot. Right, and then just look the other way and keep shooting. And this guarantees a kill. And then look the other way and keep shooting. Okay, so how about that? I think that might work, except I needed a bit more time. And also, I should probably just shoot when I see a rat. So let's say I stand up here, which I can do just... let's simplify it even more. So I do 1, 2, 3, 4, 5. 5 steps up. Or even 6 I can do. 6 steps up. I turn left. And then I chill, which doesn't seem to be possible on keyboard, unfortunately. Okay, I pressed enter and it somehow worked. Yeah, and then once I see a rat, I shoot. I just wait for a rat. But the problem is, I need to turn now. I need to turn, and now shoot rat. Which I guess can't be programmed. Right, so chill. And then, well, I know it's always going to be 4 rats. So I can unfold this loop and I can say shoot, turn. But it doesn't look like spamming the shoot button allows me to survive, although... Had I been programmed to do this, this would have... Wait, change that. What's up with these? As user's decoration? Seeing door. The door is locked. Wow. How about we take this robot and we take over the ship, because I have been abducted. Okay, so I think that might be the strat. Right? Wait, how do I kill myself now? I cannot even kill myself. Reset, please. Oh. Oh, okay. So... the difficulty is turning around. Right, knowing when to turn around. So, 1, 2, 3, 4, 5 shots, I guess, perhaps. Turn around. Wait for rat. Okay, so let's try maybe writing some pseudocode for this. And from that we can try to establish how difficult it's going to be to actually implement an assembly. But it seems relatively doable. So, first of all, walk up. Right? Let's reset. 1, 2, 3, 4, 5, 6. 6 up. This is 6 up. Right? Okay. Now that we have walked up, turn left. 1 left. Right? And now starts our routine, our loop, our idle animation. So something along the lines, while no rat, right? While no rat, chill. Then while rat, while rat, shoot. So we're just gonna shoot them point blank in the face. That's all we're gonna do, because it is a safe way to deal with them without dying, without ever having to wait for the laser to hit something, right? It will be an immediate hit. It's gonna be easy to reason about, right? So now while rat shoot, and then right, to right, to right, and this, wait, but then I'm gonna have to do 2 left. Oh, wow. Huh. Perhaps it would be easier for me to go down instead of... So again, I'm not trying to optimize for robot efficiency. I'm trying to optimize for assembly simplicity. And I think it might be more efficient if I do this. So I go up, 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 turn, chill, shoot, 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 shoot. Now, no rat. And what we do is we turn left, down, right. And then we chill. Chill, 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 chill. And then rat again. Right. Down, right, chill, 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 chill. Oops. Tab is not the chill button. Right, down, left, or chill, 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 chill. Shoot, 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 shoot. Yeah, I think that's decent. So again, up we shoot them. Now going down is gonna be left, step, left, then step, then right, and we're done. Left, step, right. Does this sound good? Seems okay. Now, a question is, I hope the game does not tick as fast as my computer does. And that would feel unfair. Yeah, it doesn't. The game only ticks when I perform an action. So I think this is probably my solution. I will reflect on this for... Well, of course we're gonna have a while true here. Right? So we will repeat this. Ad infinitum. I'm gonna think about this a little bit more, and I'll be back. Yeah, I think that'll be me. The left-right idea is enticing, so instead of going down, it would be nice to be able to turn right and then shoot. Right, and just stand in place and keep killing them like this. But I can feel it's gonna be a real pain to program in assembly, because I can't do a super simple, like, if even iteration, then turn left, otherwise turn right. I will need to keep track of so many things, right? I will need to keep track of, well, the loop iteration, or to somehow try to distinguish between different loop iterations, and to yeah, decide whether I'm shooting left or right, and I will need to remember what's left and what's right, how to turn left and right. It's gonna be a whole mess. So yeah, I think I'll go with this. Let's now try to implement it in assembly. Okay, but first, I have to go back to the previous video. I have now received comments on both the previous video and the one before it. There's been some discussion of assembly and my choices for assembly mnemonics, or if that's how you pronounce the word. For the most part, I maintain my position that I think it's nice and helpful, and people seem to agree, that it's generally good to go with conventional naming for things, even though my particular naming might not be conventional for anything. It does resemble some actual real-world architectures. But one thing that I want to change about what I currently have was also mentioned by both Christopher and Yotanido, but in completely opposite contexts. It looks like... let me first explain what the thing is. So let's go to the manual, I think. It's going to be a good starting point. Okay, you can go for now. Yeah. Is this... Yeah. So, a part of assembly features I completely missed and have been completely ignoring so far is the fact that I can add, subtract, multiply, integer, divide. Basically, I can work on my instructions. I can apply operators to my instructions inside my assembly. So, for example, I can do, I don't know, like 2 or 1, and this will be a 3. Right? And this is a possible way to implement a modular mov command. Well, it's actually a possible way to implement many commands modularly, but I think I'm just going to go for mov. So if we take a look, or rather it's going to be better to look here. If we take a look at how copy works, we have two parts of it, right? It has two parts. It has register from and register to, input and output registers. And these are really completely separate things, right? This is one register and the other register. And currently, if I need to write mov A to B and mov A to C, they are two different commands, completely separate, saved in a full package. But what I can do instead is I can implement these 2 bytes as my mov operator. These 3 bytes can be my actual registers. These 3 bytes can be the other register, and I can OR them together, right? So I can say, well, let's actually just do it right now. So I can say mov. So this is just mov. Just the fact that I am using copy mode. This is my mov, right? And now I have a from register, right? It is from. Surely it is from. I keep forgetting which one of these is from and which is to. I think this is from. Where can I look it up? I can just take a look here. Yeah, so this is from. And I can do register A as this assembly code. But of course, it's gonna be weirdness again, because I will need 2 register A's, kind of. I will need from register A. I'm gonna call it FA, from A. Yeah. And I'm gonna have a 2 register. Also, that was a completely wrong from A. From A is actually gonna be nothing. From A and 2A are exactly the same thing. So let's do from B. So from B is gonna be this, right? And then to B, it's gonna be this, right? And so now I can write mov or from B or to B, like so. And this is a weird notation. I do agree that this is really weird, especially considering the fact that we need to have different things for from and to. Although perhaps I could use more. Perhaps I could use more. Where's my thing? Is there a bit shift? I can multiply. I cannot bit shift. Well, I don't think it's really worth it. So yeah, hopefully you can see how ORing these three together results in mov from B to B. And this significantly reduces the amount of complete instructions I have to hard code at the expense of using this weird OR trick. Now, it seems like Christopher is in favor of this, and Yotenito does not like this. my two viewers are in conflict on this. But I think I'm gonna have to side with Christopher on this one, and I think this is better because it's less error prone. I'm pretty sure I've already had multiple instances of saving an instruction like movde incorrectly, just putting an incorrect code in here, and then it taking a million years to debug. So this should be much less error prone because there's less information and it's more modular. So right now I'm gonna go ahead and I'm gonna fully implement all these registers, and I'll be right back. Done. So now, as you can see, we only have a mov. We don't have mov AB, mov DC, mov whatever. And I've hard-coded all these registers. So FA, FB through F. And also, you may notice that I decided to completely get rid of load byte and save byte, which were variations on the mov thing. And instead I'm gonna use mov in and mov out. So out is, I'm gonna treat out and in as registers. So now we have this new fancy assembly setup, and we can proceed. Let's call this guy, I don't know, invaders. Not invaders. Invaders dot oml. And let's get back to our original program. Okay, but I also need, wow, I need to open so many things on one screen. I need my manual for working the robot. Where was it? It's not here. Where was it? What? How did I open it before? Check the dependency assembly. This is not it. Where's the robot? Okay, I think the level log helped me. Oops. Check robot page for instructions. Where is it? Oh, it's, so this is in manual entries, but apparently it's not unlocked. So I guess I'm gonna unlock it once I actually complete this level. Okay, so I have the robot. Let's also open the IDE. I should probably cut these things out as well, just managing windows. Sorry. I'll try to do that next time. Alright, so let's see. First, we need to walk up 6 times. I think I'm just gonna do... I'm not gonna do a loop of 6, because that's gonna be way more complicated, and idiomatic assembly is just gonna be walk up 6 times, but let's be a bit cleaner about it, and let's say const walk is gonna be 1. Right, move forward 1. So now we have walk once, twice, 3, 4, 5, 6. We walk six times, we walk up, and then const left is gonna be my 0. Maybe I should just go ahead and hard code everything. Yeah. Done. So now we have all these instructions as our constants. And let's say we walk, return left. So left. I kind of feel like separating this. I don't know. Whatever. Okay, now we're gonna do while true. So label. I want a clever name for it. What's a clever name for? Whatever. Loop. Mega unclever. And then we're gonna have to, because this is while true, we're always gonna unconditionally jump back. So this is our loop. Now, while no rat. Okay. First I will need to load. So move in. Where do I load it? My conditionals. My thing jump if happens on D. So let's move from in to D. Ah, nice, isn't it? You can just say to D. And by the way, an interesting property of this is that I can exactly equivalently write in move to D, and it won't break. So yeah, we load up. So this is load rat site. Oh, except. See now, I cannot just check for rat, which by the way, what is the code for rat? 33 space rat. I'm gonna have to, so const rat 33, something along those lines. So load rat inside. I think I'm gonna have to load it into B, right? So we'll have not enough space. Actually, I don't need the robot manual now. All right. So I will load rat into B. So this is rat question mark. Well, yeah, it's just rat. But I will want to check whether it is 33. And I want to check exactly 33. So I think I'm gonna want to subtract 33 from rat and try to get a 0. So I think this is gonna be in my pre-init phase. I can just put a 33. So first I load rat into here. Now this is not rat, this is observation really. Right? I load rat because rat is a constant. I load rat and then I move from A to C. Now I have rat in C. And so now that I load observation, now that I've loaded it, I subtract. I will get result in D. So ratness. Yeah, let's just go with res. And if my res is 0, I have witnessed a rat. Otherwise, I have not witnessed a rat and keep looping. So I will want to jump not 0. Which I could actually also make my jumps modular like the MOV, but I'm gonna bother. So jump not 0, and I will want to jump to the start of my first rat search loop. So label, oops, label rat search, like this. Rat search. I mean, it's more like a rat wait, but whatever. So this is gonna be my rat search loop, and I will keep doing it until I have found a rat. Right? Oops. Until... It's such a pain to edit without Vim. Until rat found. Now, label rat murder. Or actually, I don't even... To be honest, I know there's gonna be 4 rats. I don't even need to do this. I can just pew, 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 pew. Turn left. Step. Or walk. Actually, step is a better name. Step. Oh no. There's no find and replace. Okay, walk it is then. Walk. And right. So murder rats. Prepare for more. This is gonna be my assembly, I think. I think that's it. I think that's it. Let's test it. Let's see how it runs. Okay, where am I? Oh, this is... What is happening? Oh, okay. It's just... Wait. Oh! Oh. Snap. Okay, of course, of course. I don't just walk, I need to output walk. Can I? So let's see here. This is gonna be a common pattern. I'm gonna be doing move. Yeah, I'm gonna be doing move walk out. But since we are position independent, can I do const something like do and call it and save it as move or out? And then can I do walk like so? Will this work? Let's reset and let's see. Do walk. Oops. I think he turned left. Why did you turn left? Have I already messed up these words or something? Let's take a look at the robot instructions again, at the robot manual. Turn left is 0. Move forward is 1. Huh. How come? Okay, what is my mov? Mov is just copy mode, right? Yeah, copy mode. Let's see what out is. Well, no, clearly it reaches out because the robot does something. But the robot doesn't do what I expected it to do. I have walk 1, but it's not working. Okay, let's do a bunch more walks just to see. Just to make sure this is not a fluke. Wow, editing without actual editor. Do. Okay. Reset. Walk. Why is your walk so stupid? What? Okay, what if I set walk to 0? Nothing changes. Why? Is my do weird? Let's try move walk out. Oh. Of course. Of course. Except not of course, but of course. I need... This is completely wrong. This is completely wrong, because in order to... Wow. Yeah, I'm... You must have been screaming at the screen by now. Yeah, of course, this is not how things are done. I need to load this into a register, and then I can do things. So, yeah. That kind of makes this exercise much more cumbersome. Right, because right now I'm specifying it to copy the contents of buffer 0 or of register 0 to out, which of course doesn't work. Man, how on earth do you have highlighting for the same plugins, but you don't have editor modes or any editor features? Okay. So I can, of course, I can replace every walk with a walk and then move from a out. Is there a better way? Is there a better way to implement this? Well, I mean, I could do a loop, perhaps, but I don't think it's worth it. So let's just be generous and let's just 1, 2, 3. Oops, why not? 1, 2, 3, 4, 5, 6. 6 walks. Then left. Then red. Okay, what's up with this? What even was this? FATC. Why am I... What do I have in A at this point? Oh, I'm loading... Right. Rat is not an instruction to the robot. Rat is just a constant, which I want to... So, load rat code. Well, these are instructions to robot. I mean, I could save this as do. Should I? I'm not sure I should. See, you can go too far creating these custom things. But this is horrible. Okay, left, walk right, then go loop. Is this all? Red search, sub, move in. Load observation. Yeah. Oh, wait. In order to load... Okay, I forgot another important thing. Of course, I forgot to implement chill. I also need to implement chill. So, load observation. Well, do I first chill and then load observation? Or do I... No, I only chill... Huh. Well, I am safe to chill once. And then we're fine. So I think it's okay if I just do chill and output it. Let's see. This might work. Let's take a look. I have hope. So walk. Please walk. No walkage is happening. Why you no walk? Why you no walk? I have this. Okay, move on to the next instruction, will ya? It doesn't want to move to the next instruction. Oh, I think I broke my computer. Oops. Yep, I broke my computer. That's not a nice thing to happen. To have happen. Okay, let's restart. Walk. Okay. We're going. Turn left. Chill. Why you know chill? Okay, chill. Chill for some reason took a million years. Load observation. Subtract. You need to have 0, so now we're gonna not jump. And pew pew pew. Down. Okay. Success. So this is a shredder algorithm. I don't like the situation with walk mov FA out. Huh. How can I don't think I can improve it, right? It is, well, I could for efficiency. Yeah. I think I'm gonna do that. So I am using this register for what? I'm not actually using this register for much. I'm using register D for observations, and I'm using these two for calculating my observations. But register A, I only use, I think, where's my, there's so many windows now. Yeah, I only use register A for labels in immediate, but I don't actually even need it. So here's my idea. I will store walk command in E, and I will store PEW command in F, just constantly. I will load them once in order to avoid loading them a million times, and then I'm just gonna have my it's gonna be sufficient to just mov. So all right, I optimized it a bit. There's still room for improvement, but I think I've hit probably an relatively optimal intersection of assembly readability versus efficiency. So first of all, I added quick actions, which are achieved by loading stuff into registers. And if we take a look at what the robot does, if we think about it, most of what it does is it stands around and it shoots. It doesn't walk as much, and it doesn't turn as much. It doesn't it mostly doesn't move, right? We move 6 times once, and then we move a couple of times using left right step. But mostly it's chill and shoot. 4 times we need to shoot. How many total? Yeah, total we need to shoot 16 times, which is a bunch. So I decided that since I only have really 2 registers to spare, and the other ones are used, which I could squeeze more use out of them, but again, I feel like that would be too difficult to read. I just cache my chill action in E, and I cache my PEW action in F. And then I know that in order to chill, I just need to spit out an E, the contents of E, and the contents of F if I need to PEW. And that's what I do, right? I do chill is spit out, spit out chill, because chill is saved in TE. Same thing here, do PEW. And also, just for readability, I added a thing called now, which is just output from A. So from A to out, which allows me to quickly chain together singular action. I can say step now, which means I load step code into register A, and then I say now, and this puts step into output. And it turns out you can actually write multiple instructions per line, which I didn't actually realize before. So yeah, now we can do step now, step now, step now, step now, left now, and then we do this once we're done shooting, and then it all repeats. So let's take a look. It works. I feel like I've spent way too much on this. This video is weirdly long. I can see that we are at 45 minutes, but it's a pretty simple program, really. Did I just spend most of my time playing around with the robot? Just using my arrow keys, or what's up here? Well, anyways. Oh no, I have to solve the maze in order to not get eaten. Yeah, I am definitely not doing that today. The eatage will have to wait, or the not eatage. So unfortunately it looks like just one level today. But it was a fun one. I like the robot. I am looking forward to more challenges involving it.